Morning, good afternoon, good evening, everyone. It's very nice to meet you all. And I see that we have participants from many countries, which is really exciting, from China and Bhutan, and from Hungary, and from Myanmar, from New Zealand, from Pakistan. And we have people from India and Nepal and Kyrgyzstan. So very exciting to meet you all. And I'd like to introduce myself. My name is Tony Lynham. I'm a conservation scientist with the Wildlife Conservation Society. And I'm here with my colleagues, Nara Batdorch from the WCS Mongolia program, and Dr. Sam Strindberg from the WCS Global Conservation Tech program. And the three of us are here today to present to you about smart conservation tools. And as we're joining, I'd just like to ask you all to please mute your mic. And we're going to allow you to ask questions in the chat, and please do introduce yourself and tell us where you're from. Type into the chat so that we know who's here. And the agenda for today's presentation is here on the slide here. And we're going to start with an overview of SMART. And I'm going to talk about smart conservation tools. And then I'm going to hand over to Nara, who's going to give a presentation about Smart Mobile, the application for collecting data. And she's going to do a demonstration for us about that tool. And then we're going to hand over to Dr. Sam Strindberg, who's the main event today. She's going to talk about Smart Survey. She's going to present how Smart Survey works and how you can use SMART to collect data, design surveys, and to conduct surveys and monitoring. And she's going to do a demonstration. And along the way, if you have questions, please do type them into the chat and we'll answer them in the order that they're received, and we'll hopefully be able to answer them as you send the questions in. We're also going to have a short question and answer session at the end of the presentations. All right, so please do send us your questions and we'll happily answer them. And just to tell you a little bit about the Wildlife Conservation Society, so we work around the world in more than 60 countries where we're working to save wildlife and wild places. And Sam and Nara and I work for the Global Conservation Technology team, which is based in New York. And that team is a global team, and we're helping to deliver conservation technology solutions to field programs around the world. Nara additionally works for the Mongolia program. And if you're interested in knowing more about these programs, you can go to the website that you can see here on the slide here. All right, so it looks like we've got a good group of you here. So I think without further ado, we'll start our agenda. So I'm going to start by giving an overview about the spatial monitoring and reporting tool, or SMART. And before I start, I'd just like to ask of the people who have joined us, how many of you are using SMART right now? Maybe you can put your thumbs up, or you can tell us, type into the chat. Is anybody using SMART? Okay, we've got a couple of yeses. Great, so, okay. Yes, in Bhutan, Mongolia, Kyrgyzstan, Myanmar. Excellent, great. So today I'm going to start off by giving a kind of an overview of SMART tools and how they can be used. And this may be background for some of you who are using SMART already, but then we're going to go more deeply into how SMART is used for collecting data, and specifically how SMART can be used for designing surveys and collecting survey type data. So SMART is a tool, it's an information management platform that does many things. It's a tool for collecting data, for managing data, and for sharing data. And it started off as a tool for use with patrols, especially law enforcement patrols, but it's developed beyond that. And now it's a platform for data management in protected areas. And it's used by a range of different practitioners around the world: frontline staff, protected area managers, communities, national authorities are using SMART for their data management. And the SMART conservation tools were developed by the SMART Partnership, which is a consortium of 10 organizations that have a mission to protect wildlife and their habitats, and to empower people to use data and technology and the skills to protect those wildlife and those wild places. And so this partnership includes the organizations that you see here, including the organization that the three of us work for, the Wildlife Conservation Society. And we've been working over the last decade to develop SMART as a tool for use by practitioners such as yourselves. And currently, SMART is being used around the world at more than 1,000 sites and in more than 80 countries. And you can see the map showing places across the world where SMART is being implemented. There's many countries within the range of the snow leopard that you see here where SMART is being used. And there are a number of different government agencies that are working, that are using SMART to manage their protected area information. And that includes countries such as Nepal and Bhutan, China, Myanmar, and Mongolia. So I'm going to talk about how SMART is used for doing what we call adaptive management. So adaptive management involves the collection of data, which we turn into information that can be used to make decisions and to improve conservation. And essentially, SMART is a tool for improving the way that we do conservation. So it involves teams that go out, collect data, so they can be collecting data in the course of doing patrols, law enforcement patrols. It can involve communities going out and doing monitoring. It can involve people collecting data on wildlife. That data can be collected and then entered into the SMART database. And SMART has a desktop application, a piece of software that sits on your computer that allows you to collect the data and enter it, and then conduct analyses of the data. So SMART is a tool for doing analysis of data to produce tables and charts and maps showing where conservation efforts have been done, to show the coverage of those conservation efforts, and to show the results from the conservation work. It's also a tool for creating reports. So you can create customized reports that allow you to inform managers or inform researchers or conservation staff about what is happening in the protected area. And that those reports can then be used to create information that can be used by managers to determine what are the threats that are occurring in those areas, and how do we use the information to actually make changes. So information from SMART can be used to be fed back to create patrol strategies and conservation strategies that can then be used by the managers. So it's a tool for strategic planning. And this is what we call the adaptive management cycle using SMART. So why would we use SMART? So first of all, SMART is a tool for helping to motivate the people in the field. It's a tool to help rangers, to help the frontline staff, people who are doing the conservation, to help communities, to help researchers, and to help practitioners to do their conservation work. It's a tool that is designed to empower managers to help to create information so that managers can make the right decisions and to manage their conservation areas. It's a tool to guide conservation managers and how to use information strategically and how they can, to help them to better plan their operations and their conservation work. And it's a tool for ensuring accountability and good governance, and to provide standard measures for measuring things such as patrol performance, to measure the coverage of conservation work within a conservation area, and to help to provide indicators that can tell us how effective conservation is happening at a site. SMART allows for a standardization in the way that conservation is done. It's flexible. It's possible to design a data model to describe what is happening at a particular site. The data model can be used to create categories and attributes of data that describe the particular site at which you're doing conservation, and it can be adapted into different languages. The Smart Mobile tool, which we're going to hear about in the next presentation, allows you to collect data from your smartphone or from your tablet, and you can collect data that can be then imported directly into the Smart database. Smart is a powerful platform that allows you to conduct analyses of data, and today we're going to learn how Smart can be used for designing surveys and collecting data for surveys, such as surveys of snow leopard prey or snow leopards themselves. It's a tool that is owned by the community, and it's the developments in the software are directed by the needs of the community. And it's an open source tool that allows anybody to use it. Smart is free for use by anyone who wants to have it. And it's also possible to share data very easily through Smart being connected. We have a tool called Smart Connect that allows you to connect your database and to share the information across users within a site or within a network. So Smart has many applications. Like I said, it started as a tool for doing law enforcement and supporting law enforcement, and it's evolved beyond that tool into a tool that is used for many different purposes: threat assessment, evaluating staff performance. It's used by communities for monitoring natural resource management. It's a tool for tracking human-wildlife conflict. There are teams out there using Smart for other applications, including monitoring infrastructure. And today we're going to learn about how Smart is being used for doing wildlife surveys and monitoring. So if you're interested in having Smart, you can download it directly from the website. And here is the URL that you can use to download the Smart software. We're at version 7 of the Smart software. And if you're interested in having it, all you need to do is to go to the site and then register to use the software. Just type in your name and your email, and then you've got access to Smart. You can download it for free. And Smart is available in Windows and Mac OS versions. And it's also possible to download the mobile app, the Smart mobile app. You can download it for an Android phone or device from the Google Play Store. And you can also download Smart Mobile for iPhone. And once again, these are free apps. All you need to do is to go in and type in Smart Mobile for conservation, and it will appear, and you can download the app directly to your phone. So if you're interested in additional information after our talks today, you can go to these websites here, the WCS Conservation Technology website and smartconservationtools.org. And our emails are here. And if you're interested in learning more, you can go to our Twitter site. And this at the bottom is the YouTube for our Smart Mongolia implementation. So you can see more about how Smart is being used in Mongolia by going to that YouTube site. So that's the end of my presentation. And now I'm going to introduce my colleague, Nara Batdorch, who's going to present about Smart Mobile and how that's used for data collection. Over to you, Nara.
Hello, everyone. I'm Nara. So what is the Smart Mobile? Also, Tony mentioned it before. It is a global leading mobile data collection application designed for the smart software tools. It is also enabling georeference field observation with the photos, voice recording, and other data to be captured. And also, it's easy as using a single interface on a device. And also, it works online and offline functionality, flexible and limited number of customizable data. And of course, it supports any language with the options of icons. For example, in Mongolia, we're using the Mongolia language versions. For now, you can download the Smart Mobile applications from the Play Store and the Google Play Store, and you can just scan the QR code. This is the iOS operation system. This is the Android, and this is the iOS. Now I'm just showing how the Smart Mobile working as the cook shown. When you are ready to begin your patrol, and you can open up the Smart Mobile application and start the new patrol. And the Smart Mobile is just tracking your tracks, similar like a GPS. And when you see an observation, you can enter it into the Smart Mobile to log the location and distance. And when the patrol is over, click the End Patrol, and Smart Mobile will prepare to the patrol data for the upload to the Smart Server or the Smart Desktop version. And before we are using the Smart Mobile, we have to create a Smart Mobile package. So in the desktop versions. So I'm going to show the quick how to create a Smart Mobile package. So from the desktop version, you can go to the fields data and the Smart Mobile and the package. And after that, you can add Smart package. There's several different type of package. So for now, we are just using the patrol package. And also there is 5 different tabs of configuration. So first is model settings. It's a configuration of the data model. So we have already created for demo patrol data model. And the second one is a patrol metadata. It's all about the transport type, team, station, and the mandate, and the members. And also you have to check all the members and as a patrol leaders. The third tab is going to show the map, base map settings, and you can choose your own site map. For this, we're going to choose the small copy district protected area in the volume. The connect is when you are using the connect server, your rangers and the patrols, teams, patrols are automatically synced to the connect server. And alerts, the final thing is the alerts. For example, we're just using the position alerts. We can create our own alerts wherever you want. And for example, when your rangers and the patrols starting the patrol, and it's pumped up to the connect service. After all the configuration, just click the save button. And after that, we can export our patrol package to the connect. And after that, the rangers and the patrol team members, it's not depends on where they are based. We just using the online and using the QR. We just create the QR code for the patrol package, and the rangers just choose the scan QR code from the mobile application and scanning the QR code. And it means like importing the patrol package into the mobile application. I'm going to show how the smart mobile works after this presentation. For that, I just want to explain some new features for the smart mobile. First thing is manual GPS entry. So you can just enter your locations, eastern and north. And the next thing is now you can receive collecting signatures, which is when you are giving a verbal or written warning to the person. It is the evidence of they received your warning receipts. And also we have a distance and bearing track observer. It is helps for the survey. Also, we have a multi-reference options, and it means, for example, when we observe it to the carcasses and also the hunters, now you can add multiple reports to the one single locations. And also, there is a administrative team can create the rules and the target points. And after that, the rangers and the patrol team members can follow the patrol routes, specific routes, and also specific targets and follow the locations. And also there's tons of icons is available in Smart Mobile, new features. Around 1,000 icons is available, so it is easily to catch up, and also it increases the resolution of the smart software tools. Okay, my presentation is done. Okay, now I'm going to show how Smart Mobile is worked. So after, as I mentioned before, we just downloading the Smart Mobile package from the Connect server. And now you can see the Smart Mobile application. I just using the simulator. So in this case, in this main page, there's several menus here: maps, settings, and history, and export data, and incident, start patrol. So when we are starting our patrol, just click the start patrol. So it goes to jumping to the main start metadata page. The first thing is we should wait for get the signal from the satellite to get our locations. And after that, there's a different type of the metadata. So transport type, maybe we can choose the goods. Is it armored or no? And the team, station, mandate, and objective, and comments, and also an employees. So we should choose sample for the mandate is like, okay, there's a lot of mandate. It depends on your site. So I'm going to choose the anti-poaching and employees. We just added some members into the demo versions. It's no Leopard networking. So there is some familiar names for you. Myself. And after choosing all the members, just click on the right button. And you should have also leader. All the metadata is filled correctly. So we have to click on the right button. And it's gonna show that our observation page. And there's a make observation button. When we are making the observation, just click on make observation. So now you can see the 4 different type of categories. This is a data model level. The first one is human activity and the wildlife and the future. Patrol-related info is just additional observation type. Okay, so the most important thing is these 3 categories. So let me explain each of them. Okay, so let's go to the human activity. And there's also different type of subcategories. For example, when we are seeing the human directly, it's like people direct observation. Also, you see the camp, transports and fire, and mining, pollution, tourism, and etc. There's a lot of subcategories. It's up to you. It's based on your site. It's only based in Mongolian versions. And from the wildlife, if you click the wildlife categories, also there's 4 main subcategories here. When you are seeing the wildlife, is it a direct? This is going to direct observation. And also, if you are seeing some dung or nest, this is the indirect side. Also, there is a carcass subcategories and also trapezius categories. Go back, and there's a third category, is the features. It's not related with the human, it's not related with the wildlife. For example, if you see the historical area, the forest, earth and soil, and water point, and well, and plants and other things. Okay, let's do some observations. And maybe we can go to the human activity and choose, maybe can just imagine that we just observe the hunting camp. So we have to make an observation and click the camp. And there is an attributes related to only the camp. So we have to fill it all the attributes. For example, the main activity. So main activity is like hunting. And also infractions. So these infractions are also based on Mongolian real law of the protected areas. So maybe illegal usage of natural resource, click them, and searching the hunting endangered animals. Okay, of course, it's a hunting camp. That's why hunting endangered animal. For the status of the camp, it's active. It's also inactive, unknown, abandoned. If there's any name of the camp, you can write it. And also, if there have any permission, you can check it. And the toilets, action taken. Okay, I just observe it only. If there is any fine, you can fill it. If there isn't any comments, explanation, you can write also there. If any other attributes should be filled correctly, just click on the right top button. And you can see that our camp observation is appeared in the top. Now we have to save our location of the camp. So in this case, we just click on the save button. Now it's saving the location of the camp. And you can see our camp observation is disappeared. So all the observation is moved to the history. So you can see my camp observation there. We go back, and now we can make a wildlife observation. So and just go, and there's some snow leopard. Imagine that there is one male snow leopard. Okay, so make an observation and choose the wildlife. And this is a direct observation. So we just saw the snow leopard. So click the direct observation. And this is the attribute of the direct observations category. So first thing is species of the wildlife, and click them. So this is, we just add example of species in this demo. So we're gonna choose no Leopard. Okay. And there's also infraction. This is just no infraction. We just choose the no infraction. There's no Leopard is alive. If it's possible to identify the sets, so you can write each of them. If it's not possible, you just write the number of age of or sex unknown. For me, it's like one male snow leopard. Okay. If there any sign of disease, you can check it. If no, just leave it. All the attributes is filled correctly. Just click on bottom right up, and you can see the right of direct observation is occurred. So now you have to save the location of the snow leopard. So click the save button. Now we are saving our snow leopard location. Okay, now it's also disappeared. It's going to history. You can see the wildlife direct observation here. Back. And now I'm going to show the how to make multi reports in the one single location. And maybe we just imagine that there is a illegal entry into the protected area with the vehicles, the one man. So let's make an observation. So in this case, we have a two observation. The first one is a human direct observation. The second one is vehicle. So it's all related about the human activity. So just take the human activity and the people direct observation. The first we just observe the human. Okay, so all these attributes are related to the direct observation of the people. So first thing is infraction. So I'm going to choose violation of zoning regulation and choosing the illegal entry into strictly protected area. After that, action taken, maybe a verbal warning and number of people, only one people. And you can write a name. Also, okay, a male, and the person age, nationality, maybe, okay, it's Mongolia. And you can fill all of these attributes. For example, equipment type, maybe he's bringing some shotgun, and also maybe chainsaw, knife, whatever it is. In this equipment type, there's a multiple multiple type, choose multiple options. Click OK, and after the type of ammunition, also it's okay, wherever you want, and serial number, phone number, and also an additional explanation. So after all attributes are done, you can just click on the right top of the button, and you can see the people direct observation here. And then we just skip for this save button because we need to make an observation for the vehicles. This man is using the vehicles, driving the vehicles. So add observation. We just click the add observation and go to the human activity. And there is a transport and vehicle subcategories. So you can just click there. And this is all related to the transport vehicles. So first one is type of transportation. So there's a different type of car. So infraction is a similar like direct observation, is violation of zoning regulation and illegal entry into protected area. So also there is a country number, registration number, name of owner, also name of driver. Name of owner and name of driver is separate things, and also action taken. Maybe we can verbal running, and if there is a file, you can write. All this attribute is done. You can just click on the right of the top button, and you can see the two observations here. So we have direct observation and transport and vehicles. Now you can see the location for those two observations in the one single location. So click the save button. Now we are saving the location of is entering our strictly protected area illegally using the vector. So go to the history. You can see the our observation here. And now we want to start end the patrol. You can click the patrol boots button of our menu. So click on the patrol boots. There is the end patrol. So click the end patrol, and it's asking end patrol. So click the yes, and it's saving our final locations. And now it's going to the main pages. Now you can go to this history. You can see our patrol information. If you click each of them, there is a details of the observations. Hunting, endangered animals, and active, this kind of stuff. And also there is some function is here. You can see the right top button. If you click on this, there is some information about the distance and the average speeds and start date, start time. Now the final thing is now you have to export data to the administrative team and also the Connect server if you are using the Connect server, and click the export data. It's automatically sync it to the Connect server if you are using click OK. Now it's like finish almost. After that, your administrative team members just download from the Connect server and see your patrol results. Now I'm finishing my demo how the Smart Mobile works. So if there are any questions related about the Smart Mobile, I'm happy to answer.
Thank you, Nara. So I've been answering questions in the chat here, and at the end of the session, we'll have a question and answer session. So thanks very much for that presentation. So now I'm going to introduce Sam, who's going to introduce us to Smart for surveys. Over to you, Sam.
Thanks, Tony. So it's really my great pleasure to be here with all of you and part of this series of talks to the Snow Leopard Network. Thank you very much for inviting me along. As Tony said, I'm part of the Global Conservation Program. I'm a wildlife statistician, so I support our field sites with their survey designs and their analyses, but I'm also part of the conservation technology team that Tony mentioned together with Tony and Nara. So what I hope to do is to be able to provide you with a brief introduction to Smart Survey. And for those of you who've heard about Smart for the collection of ecological monitoring data before, it used to actually be called Smart Ecological Records, but now the name's been changed to Smart Survey. And what I'd like to do is place this technological innovation within the context of ecological monitoring, the selection of an appropriate survey method, as well as survey design and the analysis of the resulting data. And I'm going to show you some examples from our Ndoki-Likwale landscape in northeastern Republic of Congo. And some of you who've heard a previous talk we've done may have seen this example before, but it really is one of our best examples in that it covers a survey that's really extensive and where Smart Survey has been hugely helpful in the collection and management of the survey data. So, in a nutshell, Smart Survey is a plugin that can be installed as part of the main smart system to help with the collection and management of ecological data. And Smart Survey mimics the hierarchical framework used for smart patrol data. So for those of you who've used it for law enforcement and the collection of patrol data, things will look pretty familiar to you. And we'll look at the various elements in a little more detail in a moment. So basically, once you install Smart Survey, a new survey menu appears, and that which has a number of options, which we'll look at. But I think before we get into these details, it might be useful to cover a couple of definitions and give you some examples to make sure that we're all on the same page. So firstly, for our purposes here, when we talk about a survey, we mean the collection of a sample of observation-based field data. So generally, we mean human-based observations rather than data collected by means of taking photographs, video, or other digital data that might be collected using different sensors. And the target of these surveys can really be a huge variety of animals, their sign, plants, habitat, or human-related features. On the bottom right there, you see sort of cartridges, gun cartridges. And the surveys can be completed in a variety of habitats, on foot or using various modes of transport. And the survey method that you end up using will really depend on the target species and the monitoring question of interest. So for snow leopards in particular, you might be interested in monitoring the animals themselves or their prey and habitat. And I thought this figure from the Singh and Milner-Gulen paper very nicely illustrated how the survey methods and modes of operations change as a function of the habitat features. And remember, we're not focusing in this case on the camera trap option shown in this figure, although you might use Smart Survey to collect data around your camera trapping, for example, the locations where you place the cameras and habitat data may be associated with that location. Unfortunately, or perhaps fortunately, in terms of somewhat reduced human pressure, snow leopards and their prey occupy difficult terrain frequently, and they tend to be found in remote and large geographic areas, which makes surveys challenging. I'm pretty sure that I'm not telling you anything you don't know already here. Fortunately, though, you have a very comprehensive manual and training module on one of the more frequently used methods, the double observer method, that's often used to assess the status of the prey base. And this method relies on mark recapture type of analyses using data from independent observers. And the trick is to ensure that the independent observers cover the same areas, and one is able to correctly figure out which animals are recited. And so by the end of, once you've applied the double observer survey method, you basically get abundance. Another method that could be very useful over larger areas for both snow leopards and their prey are occupancy sampling surveys. And those are based on detection, non-detection data, possibly just of indirect sign rather than the animals themselves, or even through sort of questionnaire surveys of members from communities living in the area of interest. Those are data that could also go into this type of sampling. And depending on the size of the grid cells that you use as your sampling units, there might be grid cells, you might decide to define sampling units a different way. You will then end up with a probability of occupancy or use across those grid cells or sampling units. And the good thing about this method is that it does something you really want any method that you're using for surveys to do, and that is account for detectability. And all the other methods I mentioned here do the same thing. And that's really important for robust monitoring in both time and space. Another thing to mention is that you need a good number of sampling units when applying either this occupancy method or other methods to be able to actually detect those trends in space and time. So here's just an example of where occupancy sampling was used over a very extensive area across potential tiger habitat in Karnataka, India. And you can see that, yeah, it really is a very large area that they basically covered during this survey. So when it comes to snow leopards and their prey, something like strip transects or plot sampling may be more applicable sort of for dung surveys of prey species or perhaps habitat studies. And again, the type of data you collect is the counts, and you note the species, and you end up with the density and abundance. And of course, if it's dung survey, then it's a relative density and abundance. You may, for example, be interested in the degree of overgrazing and whether habitat is likely to be able to support a suitable density of snow leopard prey species by doing vegetation plot sampling. And one method that is used very extensively in wildlife population assessment is distance sampling along either lines or at points. And applying this method to snow leopard prey can certainly work in some circumstances. Generally line transects are more efficient than point transects, but in very rugged environments, it may make sense to use point transects. And at the core of the method is basically recording distances to your observations, along with information on group size and species. And the key is to get these accurate distance measurements that then allow you to figure out your detectability and basically the proportion of animals that are missed during the survey. And here is an example where we've applied line transect distance sampling in a very large area of the Gobi that is slightly less rugged. And these were vehicle-based line transect surveys for ungulates, where the observers recorded the radial distance and compass bearing to the animal groups. In these sort of really large areas, ideally, aerial surveys would be used because they can be very effective, and they can be combined with using smart survey. But often the aerial survey costs are very high, and it's difficult to get permission to fly. So yeah, ground-based surveys are frequently still used. In an area, for example, like in Western Mongolia, that is more rugged than that area in the Gobi I just showed you, it was still possible to use line transects distance sampling in this case for Saiga. But then in a smaller area, in the small Gobi sort of area, more to the west, we decided to use point transect distance sampling because that seemed a better option. And so you can see the different points that were sort of sampled from. The green is sort of the view shade, how much you can see from the point, because sometimes you're not at the highest altitude, say, and there's sort of a mountain obscuring your view. And so these surveys were mainly for coated gazelle and hulan. And more recently, what we've started using a lot is something called camera trap distance sampling, where the human observer is replaced by a camera. And I can imagine that this could be a very useful method for estimating the density of snow leopard prey. But as I said before, you wouldn't use Smart Survey to record those data, but maybe just to manage your data around the camera traps to keep track of their placement and general habitat. So having given you some overview of maybe potential methods that might be useful to you in the snow leopard network, whichever method you end up using, you know it's always worth applying a random survey design, as then you're on more solid footing to draw conclusions about your entire study area. And as you work on your study design, there's always this sort of tension between the perfect design that gives you great precision and allow you to detect trends versus, you know, the resources available to you, the logistical constraints. So it always requires basically a careful balancing act. And the other thing which sort of relates to what Tony said about adaptive management is, you know, that we'd really like to be sure that, you know, our survey results allow us to assess whether or not our threats, maybe they're, you know, unsustainable or illegal hunting, whether those are decreasing and our wildlife populations are increasing. So the monitoring that you sort of set up basically helps you test assumptions. You know, are the interventions actually leading to what we want to achieve, or are they wasted effort and they need to be redesigned or, you know, changed for different kinds of interventions? So in this example from Congo, you know, does law enforcement or conservation education for kids actually change the levels of poaching, and does that result in an increase in forest elephants? You know, would law enforcement and community engagement result in an increase in snow leopard prey densities, as another example? So successful monitoring is much more than counting plants and animals over time. Its success really requires monitoring to be placed within the context of monitoring frameworks so that we can figure out if our interventions work and what should be changed if monitoring shows that things are not going to plan. And this applies both, you know, in the context of ecological and law enforcement monitoring. And the thing we ideally want to avoid is inconclusive monitoring results where we're not sure what our management response should be. So now I've hopefully given you a bit of a backdrop of where sort of Smart Survey fits into the bigger scheme of things as you think about your monitoring methods, setting up your monitoring frameworks. So let's take a little bit of a look at Smart Survey now in more detail through the experiences of applying the technology to our Ndoki-Lekwale landscape in the Republic of Congo. And here the conservation targets include forest elephants, great apes, both western lowland gorillas and central chimpanzees, African grey parrots, and various ungulates. And we've done a series of landscape-wide surveys, basically to assess changes in these target wildlife populations over time. And during the previous round of surveys in 2016 and 17, Smart Survey was used for the first time. We're actually busy completing these surveys again using Smart Survey, but they're currently ongoing and should be done in November. And Smart Survey has really been useful in both the collection and subsequent management of the data. So you can see, you know, it's a really huge area of almost 35,000 square kilometers. This is an example of the survey design from the last round of surveys. really a huge amount of effort, and it includes a landscape with a national park, Nobalindoki National Park in green up here to the top left, and then a community reserve, Lactele Community Reserve, that are surrounded by several logging concessions, and then there's a swampy area in light blue, and then an area of particular interest for great apes and dwarf crocodiles that enjoy that other swampy area called Batanga. So this survey design really maps onto what is referred to as a survey design within Smart Survey pretty seamlessly. And that it's basically a template for survey data collection. So within Smart Survey, as you'll see in a moment, we also define a number of elements related to the survey design, namely the survey properties, the mission properties, and the sampling unit definition. And there are no data associated with the survey design itself. Associated with the survey design within Smart Survey are the surveys where the observational data are collected by visiting all the sampling units at least once. One or more missions are associated with each survey, which is basically a single complete set of the survey data. And during the missions themselves, survey teams go to the field to collect the survey data. So in the case of our Congo landscape, the teams went out. There were several teams because it's such a huge landscape, and many missions for each team because the entire survey took over a year to complete. And the field teams would go out and collect those data on those distance. In this case, it was a line transect survey for elephant and ungulate dung and great ape nests, and they would take the distances to those observations as well as direct observations of the parrots. On this, just to note on this image, the blue lines are basically the tracks the teams followed as they were moving between the sampling units, basically the line transects. So a first step really is to define your survey observation categories and attributes within Smart Survey. And you can do this either in the existing sort of conservation area data model, and I'll show you that within Smart in a moment. It's basically the model underlying the Smart system. So, you know, all those attributes that Nara showed you a moment ago are defined within a database within the Smart system. The other thing you can do is, for Smart Survey, is define a configurable data model. And that basically adapts the conservation area data model, you know, for the specific needs of your particular survey. You don't have to have a configurable data model, but it often speeds things up in terms of data entry and retrieval. And the configurable data model can also be associated with more than one survey design. So for example, if you set it up, you know, a separate survey design for two different areas of interest where you're collecting the same type of data, then you can use the same configurable data model in both cases. Another thing that needs to be defined at the global level when you're setting up your survey design are the mission properties. And you do this by selecting it from that survey menu. And these mission properties can then be applied to different missions, and they're created in exactly the same way as you do when you're defining attributes within the data model. And again, we'll take a look at this when we look at Smart Survey in a moment. So you just basically keep adding properties until you have everything you want in terms of your mission properties. You know, for example, maybe you want to define the survey season and a sector property that would be associated with each mission. so that you know when the mission was completed, was it spring, summer, or fall, and in which sector of your conservation area. So once you have defined those mission properties, then they're basically available for selection later on. And then the next thing you need to do is at the global level, set up sampling unit attributes. And again, this is done by selecting that item off the survey menu. And the process is the same as defining data model attributes again. Now, as for the mission properties, you'd define sampling unit attributes that make sense for the sampling units you plan to have for your survey. Maybe if you're doing point transects and you have a rugged landscape, you want to know the altitude of the point, the exact location, in case it doesn't map perfectly onto your original design. You want to know who the observer is, maybe associated with that sampling unit, and maybe the sampling fraction. So maybe you can't see 100% of the area around you because some of it's blocked out by a high mountain. So the sampling fraction, for example, would capture that. So once you have those three elements in place, the observation categories and attributes you need, those have been defined within your data model, you have your mission properties and your sampling unit attributes, then you can take the big leap of creating a new survey design. And there are a couple of initial options that include selecting whether or not to record some additional info for each observation, namely the distance and direction and the observer. The SMART will allow you to record locations, for features of interest, and the location will be that, of the observer recording the data. So when Nora showed you the demo just now, every time she sort of took data for an observation, it also recorded the location, but that would have been where Nora was standing in the field, if she were in the field. So, if you have a survey where observations tend to be further away from you, then you may want to know exactly what the location of the observation is. And then if you click here, record distance and bearing, then SMART will basically use that information to give you the actual location of the observation. And then here you also have the option to record the observer at this level. And then the second thing is you tell it which configurable model you want to use. And again, it could just be the basic data model, or it could be a model that you've set up specifically for the survey. And then you select all or a subset of those mission properties that you previously defined. And you can also specify at this point some of the survey properties. For example, maybe it's a point transect distance sampling survey with 100 sampling units. And you would select all or a subset of the sampling unit attributes that you defined earlier, and then import the actual sampling units either from a shapefile, usually from a shapefile, but you could also import from a text file. The attributes associated with the sampling units. And basically to finish up, it asks you if you have anything, some description that you want to enter. And then you can go and sort of click on a button to import the sampling units or update any attribute information. And you have a choice of, usually the sampling units are lines or points. And what we've done frequently, like for the Congo surveys, is use the distance for Windows software. There's also an R version, a library called DSSD, Distance Sampling Survey Design, where you can create designs, or you can do a lot of it in GIS if you want to. And so for Congo, we have a systematic survey design with a random start within each of the survey strata. And which basically cover our entire landscape of interest. And yeah, we had 2-kilometer transects basically in this case. And the design is, you know, if you create it in distance, is already saved as a shapefile. And so it's really straightforward to then take that shapefile and import it into Smart Survey. You may also have a survey design that you've created elsewhere and exported, which you can just import directly into Smart. So, you know, once you have your survey design in place, then you use that as a basis for defining your surveys. And firstly, you give the new survey a name, and you then go on to basically create individual missions to collect data for the survey. And when you're defining the set of one or more missions associated with the survey, at that point you tell Smart the date range, when are you planning to go and actually collect those data. So part of creating a mission involves defining the team members, pretty much as you saw Nora show you earlier, basically who's going to participate, and you select them, and you also select from the available mission properties, which sector you're covering in this case, which season are you going in. And then, as Nora said, once you have all that set up, you can go and export all that information as a survey package, and you upload that onto your Smart mobile app, onto your device, and then you're ready to go and collect data in the field. So here you can see, observers taking the careful distance measurements from line transects. As I said, they're mainly dung and ape nests. And the interesting thing here is that we use both Smart Survey as well as an old-fashioned notebook in the case of sort of damage or loss of the digital equipment. We want to know that we still have the data just in case. So, given the large extent of the area, many missions, as I said, were needed to complete the survey. And in the middle, you can see an example screen where you might have when selecting one of the sampling units, one of the transects that you're about to cover while in the field. And on the right is that same image showing you just how much walking the teams had to do to complete the survey. So here again, an example screen of how things might look when you maybe observe an elephant dung pile and want to record the relevant data. So each time a mission is completed and the field team returns, the data are basically imported into the main Smart Survey system from the mobile devices. In the case of this landscape, we don't always have connectivity, so the field teams can't necessarily upload in real time. So usually they come back to the main office and upload the data to the main system. So there are several options for how this sort of data import can be done. And basically you would import the data for an entire mission, usually all at once. And you may have noticed in the earlier slide that when you set up a mission and you tell Smart, your start and end dates for the mission, then Smart actually creates a tab for each day in that date range, and then allows you to import the corresponding data when you sort of come back from the field. So generally you start by importing your tracks showing the paths taken by the field teams. And this usually involves some editing, which you may do some editing before you import the tracks, depending on just your preferred workflow. But you can also do editing within SMART itself. So you can use something called the track editor to manipulate the track data so that it basically corresponds correctly to the sampling units you've defined as part of your original survey design. So you don't want to maybe include all that track that is there between sort of when you're actually on effort collecting data. And so you tell Smart Survey, how to match your field data to the sampling units that are part of your survey design. So here you can see an example of importing data from the Congo survey. When you yourself import data, you'll be able to see the data on a map like this one, or in a table, and that's very handy in terms of data validation. And when you import waypoints or observations, you also have different import options available. And again, you have to match your field data attributes to those you defined earlier. And this way, you really get a chance to also check the data as it enters into SMART. And again, looking at the observations on a map, and this is an example of the Congo data. It really makes data validation a whole lot easier. So the procedures for entering data, sort of for ecological surveys, are pretty similar to those used when entering law enforcement data, for those of you who've worked with law enforcement data, except that you have those choices about whether to use a configurable or default data model. And as I mentioned before, the configurable model is often very much more efficient when it comes to data entry. So once you have the data imported, you can then move on to some survey queries. And in fact, you can use queries as part of your data validation process. And there are several options to choose from in terms of survey queries. And again, they're pretty much, they're very similar to what you can do with law enforcement data. You have queries about your actual observations, about something that you sort of mark as an incident. You can get summaries about your mission tracks. There's all sorts of different things. Gridded surveys give you a nice spatial representation of your data, because you can put a grid over your area of interest. So there's a lot of different options and things to try out. So, generally the results of queries, they again can be viewed in either a table or a map, which is handy. And this is an example of a query to find the locations of illegal hunting camps. In Congo, we when collecting, during the wildlife surveys, we actually also collect a lot of data on human activities, because in terms of our analyses, the sort of human pressure elements go into the analyses, and in terms of visualizing the data as well, often where the wildlife are is sort of a mirror image of where the people are, and it's interesting and informative to see that. And a final feature available within SMART more generally is this option to create reports. And this is really handy if you need to produce regular reports with some sort of basic ecological survey data summaries. You can set up a template, often linked to data queries, and then if new data come in, you can run the query again and you get an updated report. So it can be very useful, especially in the law enforcement context, where you might more regularly get data that you want to summarize and report on. And often for the more complicated and comprehensive analyses, you would export the data from SMART into whichever analysis software and use whichever analysis software you want for your particular data. And for the Congo data, of course, it was distance sampling, so we did distance sampling analyses using either the distance software or the R libraries. And one feature that they did add a couple of years ago was an extra option that allows you to export data in a more streamlined fashion for a distance sampling analysis, for example. So there was a tour of SMART survey in the presentation at high speed. We'll also look at a little demo in a second, the actual software. And basically, it's a handy tool for standardized data collection, validation, storage, and retrieval. But ideally, the technology, should go hand in hand with informative monitoring frameworks linked to appropriate survey methods and good survey designs with rigorous statistical analyses. So that's more or less the presentation. I think maybe it makes sense to hold the questions until after we've had a peek at the software a bit more. So basically, we set up a demo, or actually Nara helped set up this conservation area for us. It's the small Gobi special protected areas and in Mongolia. And it's based on the law enforcement monitoring data model, which she made some tweaks to. So in terms of design, I just did a pretend design. I pretended we were going out to collect distance sampling data from points. I created that design using the distance software. And I then had a look at on Google Earth how those points looked across the terrain, which is something you would probably do when you're actually going out to collect the data to figure out how to move between those points. Ideally, you'll be doing these surveys together with people who actually know the survey area. So it would, looking at Google Earth and having people's experience, you would know how to move between your different sampling units. So let me now hopefully show you how this looks within the SMART survey. So here we have SMART and the same conservation area you just saw in the presentation. And it might be worth just showing you what the data model looks like, because it's kind of interesting, because you'll see how what you just saw, so in Nara's presentation, maps on very nicely. So you'll notice, first thing you'll notice is that the main language here is Mongolian, because it's the original version of this is used for law enforcement in Mongolia. Fortunately for me, you can also have a second language option, which you can select to see the details in English in this case. So here you see the same categories that Nara showed you. You have the human activity category with different subcategories and attributes. You have the wildlife. You have those same features you saw in Nara's demo, plants, and then patrol effort. So it's a very extensive sort of data model. And part of sort of when you set up your own SMART system, often you'll want to maybe not start from scratch, but if you're going to do a survey, maybe you have some law enforcement activities where SMART is already being used, and you can borrow their data model and then adapt it for your needs with SMART survey. So that's what we've done, mainly Nara has done. Basically create different configurable models. So in this case, for this example, we've used the survey configurable data model. And there you'll see that it's basically a simpler version of the entire data model. So we've decided just to include wildlife and then some survey info. And so some nice things that you can do within SMART in general, when you create configurable data models, you can sort of create aliases. So maybe SMART, this used to be called patrol info, but now you're doing an ecological survey. So you know, when you go out to the field, you want this category to be called survey info instead. And so you can have these kind of aliases to make things, you know, adapted for your particular survey needs. So another thing that's kind of useful, so in this case, I had added the type of survey info to do with weather. And the interesting thing is that subsequent fields can be turned on and off depending on what you've selected at a previous stage. So if you select start or end, in this case, precipitation wouldn't show up. So only if you've selected the sort of weather type would you then get the subsequent fields that allow you to enter information on precipitation and wind speed. So precipitation in this case is a list, and you would select one from this list. Wind speed is a numerical variable, and so you would enter a number. And when you're setting this up, the nice thing is that you can also put in some data validation. So you know wind speed is never going to be less than 0 and never going to be more than whatever, some upper limit where you would go and survey in. And so you can set all that up within your data model. In this case, because we're doing an ecological survey, we've also deactivated some of the things related to law enforcement. So things like action taken. We wouldn't take actions during an ecological survey. So that has been sort of disabled. And so you just, it's very simple to do. You just basically choose never from that drop down list. If you want to enable it, you just choose always, or if you want that custom thing I showed you before with the weather, you would choose custom and then define when it should appear and when not. And for carcasses, probably you don't want the bearing and distance, so that's been disabled. Similarly for wildlife, indirect sign. For wildlife direct sign, we do want the bearing and distance. And the nice thing is it's very easy to move things around. So if we decide distance is really very important, we can move it ahead of bearing to make sure that that's the first piece of information that's entered. In this case, Nara created a very much simpler list of wildlife species, as she mentioned. So rather than having the sort of huge tree of things that you could possibly, the whole universe of options that you could choose from, which is a very long list of things. We simplified it to a shorter list of things. And the nice thing too is that you can have icons associated with each type of observation too. So you can choose whether you want just text, just the icon, or both, as you sort of do your data entry, which is very nice. In this case, we'll also record. We had an observation type, seen or heard, but we're only going to record things that we see, so we've disabled that. We do want to record the total group size and the number of young. We're not going to, because usually we're recording from quite some distance. We don't think that we'll be able to get the information on males, females, etc. So we disabled that. We've left in the sign of disease. We added a behavior category, and this is actually a multi-list. So if you have a group of animals, they might be doing, some of the group might be lying down, some might be standing, some might be feeding. So you can actually select multiple options. And so here we see, there's a general habitat type, but we might be interested in a more specific local habitat, which could be used in the analysis because it might influence detectability. But now we actually, to include that, because we need to go back to the overall data model and include it there before we can see it in our configurable model. So in this case, we go back to our overall model, and we basically add it there. So we want to put it only for wildlife direct observation. We want to add an attribute. So sometimes you can select it off attributes that exist already, but we'll see that in terms of habitat, there's that overall general habitat type category, which is not, we want to now refine. So we create a new habitat, a new attribute, and so maybe we call it local habitat, and it's going to be a list, and it's going to be a pretty short list. As you saw in the presentation, it's pretty straightforward to add things. So we just do that. So our two habitat types are Saxel, which is basically this. Spatial is like this bushy plant. It's not too high, but it can really reduce detectability, especially for gazelles. So we're interested in this case in knowing whether the environment is predominantly Saxel or if it's just open habitat. And now we save that addition to our overall data model. So now we have something called local habitat there. We close this one. And if we go back to our configurable data model now, we should be able to see that. So we can resize it, then we can see hopefully that now under wildlife direct observations, we have that new category that we can use. So that's just, it's pretty straightforward to add things. The more difficult thing is thinking how to structure your data model, how to have those different groupings of attributes, what kind of categories you want. The actual adding of the data and manipulating your data model isn't, after a little bit of practice, isn't too bad. So now we have basically the configurable data model that we want to use, in this case, our survey data model. Remember, the other thing that we needed at the global level when setting up a survey design was those mission properties. And so I've already set those up. We have season with spring, summer, and fall, and sector, the east and western sector of this survey area. And the third thing we needed were the sampling unit attributes. And as you saw before in the presentation, I set it up as having, altitude, the specific location of the sampling unit, in case you have to move it from the original designed point, your observer, and how much of the area around you see as the sampling fraction. So once you have that, you can actually go ahead and create your survey design. So new survey design. In this case, we're going to create a blank survey design and call it small OV special protected area. I don't want to record these extra attributes, so I'm going to leave them out for the moment. I'm going to use that survey configurable model that we created specifically for the survey. I'm going to add both of the mission properties. And I'm going to say something about, give some description of this survey design. So maybe I'm going to define the method as point transect distance sampling. And I'm going to say that the total sampling units are 71, because I happen to know there's 71 points in my shapefile. Description, maybe this is a summer pilot study design. So now once you set that up, it basically gives you the summary of all the data you've just sort of entered. And it also creates different tabs. Obviously, the survey data tab is empty for the moment because we don't have any survey data yet. And under the sampling unit tab, that's where you could tell it which of the sampling attributes you want to add. And you can also, at this point, tell it where to import, where to find the shapefile with your sampling units. And that shapefile may have those sampling unit attributes in it, or maybe you have those attributes in a CSV file. So you can also, once you've imported your sampling units, you can update the attributes associated with those sampling units. So in this case, we want to add in our points, and it's a shapefile. And I want to use my original ID so I can map it back to. So now we have the points, and that's basically our survey design complete. So step one done. Excellent. Now the next part is, of course, creating a survey associated with that survey design. So new survey, we tell it, yeah, please link that to my survey design that I've just set up. I call it something. So now we've got the survey. So remember the hierarchy: survey design, survey, and missions. So the last thing to do is to actually create those missions. Again, we're just reminded which survey design, which survey, and we call it something relevant. And we choose, when are we going to actually go and collect these data? So we'll do that next week. And everyone's going. And we're going to make Raki our mission leader. So maybe we call it when transect business sampling training mission. And we're going in summer, and we're going to start off with the eastern sector. And so that's it. Basically, the mission is set up. And so again, it regurgitates the information you've just sort of entered, and you can edit here too if you decide, well, someone can't make it. You can remove them from the list of members for this mission. And it also creates a tab for each day in that date range, as I mentioned before. And so here, when you come back from the field, is where you would import the data and see the actual survey data. And so once you've got all that set up, the last step is basically what Nara already mentioned, is that you go from the Smart Mobile menu and to Packages, and you export the survey package. You have the survey, you have the survey design, and then off you go. So I think that was more or less what I wanted to show you within Smart Survey. So hopefully we have some time for questions now.
Thanks, Sam. And actually, we've had a number of questions in the chat, which is really fantastic. And we'll keep on responding to those questions that you type in. But yeah, thanks so much for that presentation of Smart Survey. And thank you, Nara, for the presentation about the Smart Mobile application. And as you can see, and as I've been typing responses into the chat here, Smart is completely adaptable for use with any particular purpose, whether it be a patrol exercise, a community monitoring exercise, or a survey. And you can adapt a data model that can fit the needs for your monitoring purpose, and that can go into the Smart Mobile application as what we call the configured model. We also had questions about whether Smart is available offline and online, and it is. You don't have to be online. It can be in a remote, it can be used in a remote situation where you don't have any connectivity at all. You can be collecting data, and the data gets stored on the phone. And at such time that you're ready to bring the data into your Smart desktop, you can either do that manually through a USB cable, or you can use the Smart Connect application to import the data wirelessly into a remote copy of the database. And then from the remote copy of the database in the cloud, it can be downloaded to your desktop. So Smart is very configurable to any particular field purpose. and it can be adapted into any language. So we mentioned that the smart software is available in Russian and Mongolian and Chinese. Those are the languages in some of the snow leopard range countries. But if you wanted to use it in Nepalese or Bhutanese or in Myanmar, you can do that on the smart mobile application. All you need to do is to configure your application so that it is using what we call a backup language. So the backup language is the language of the system that your computer is using. So if you're in Myanmar and you want to use Burmese and your system is in Burmese, then Smart Mobile can be configured so that it's using Burmese language. And then you can just type in a name for any particular category or attribute. You just type in the particular word for that category or attribute in that language, and then it will appear on the mobile app in that language. And it's also possible to configure Smart so that you have icons, and Nara and Sam showed you slides showing that there's a range of different icons. I think there's more than 1,000 icons that are that can be used with Smart Mobile. So you can have an icon or a picture for pretty much any object or any type of observation that you might think of. So that could be animal tracks or animals or threats to animals, snares or weapons or any type of thing that you might think of recording can be iconized, and there's a selection of icons that you can choose from when you're configuring the data model for use with the application. So yeah, let's have some questions. So Lanai, who is my colleague from Myanmar, formerly from WCS Myanmar, and now he's in Myanmar. Thank you for joining us, and just great to hear from you. Your question is, your question is about the use of Smart and its power. And so there are ways that you can get information about Smart and the training manuals. I've actually put a link into the chat here where you can get access to all of the training manuals from the Smart website. So there's a link. I'm just going to type it in again here so you all have it. If you're interested in getting any of the training resources, the manuals and information on the technical aspects of Smart use, just go to that link there and you can download it for free. And on the website, we have a range of different manuals. We've got the basic. I'm just going to share my screen here so you can see. So first of all, the technical training manual, which is this document here. This is the Bible of how to use Smart, and it's about 300 to 400 pages long. And from this manual, you can find out how to get up and running really quickly. And this will take you through how to set up Smart and how to get it onto your desktop. It will also tell you how to load it onto your mobile application, onto your device as a mobile application. And it can also teach you how to set up Smart for use in a network with Smart database in the cloud. If you're interested in using Smart in a network situation, you can set it up for free using what we call Smart Connect as a service. And if anyone is interested in that, please just write an email to us and we'll connect you with the Smart Partnership, and we can have you set up with a free copy of free access to a cloud server. We'll set that up for you for free and you can use it for free. So the other training resources that are available from the website, first of all, the Smart Mobile manual, and that's downloadable. And once again, that gives you the step-by-step how to set up Smart for use on a device. There's Smart Connect, the Smart Connect training manual, and there's a manual on advanced reporting, and this one here, the Smart Survey Manual, which Sam in fact wrote with support from the partnership, and that's the text on how to use Smart for use with designing surveys and collecting data for use with surveys. So those are resources. Like I said, they're free resources available to anyone. All you need to do is to register on the Smart website. You can go to that link and you can just add in your name and your email, and then you've got access to all these resources. Raki, you asked, whilst generating reports from the app, does it allow for including graphs, pictures, and charts? And the answer is yes. So as Sam mentioned, it's possible to create reports, and you can configure reports so that they can include various different types of objects. So that can include grids, it can include graphs, charts, maps. You can also include tables of data, and you can bring in data from the database, from the Smart database, as what we call queries. So if you want to create a question or an information, a piece of information, you create a query. And so the query can be, for example, a table of data, or a query can be a map showing the location of something you're trying to measure, like locations of carcasses. Or a query can be a query about the patrols. It can be a query about where patrols went to or where surveys went to. And so if you're interested in knowing the track logs of the surveys to see where survey effort was made, you can create what's called a survey query that shows the track logs of where surveys occurred. You can also create a gridded query to show you where surveys took place and the spatial coverage of survey effort in across a survey area. So all of those things are things that you can create within the Smart database, and then those pieces of information, well, those queries can be imported into a report and formatted for sharing with your colleagues.
Ricky, you had a question about the training in Mongolia. Were you interested in Smart training or Smart survey training? Is your focus on the law enforcement or the survey element?
I just thought that we could perhaps let our team in Mongolia know, Sam, so that in case anyone was interested, we could send them the details. And because it's going to be in UB, and I think it might be useful for them to know that it's a training is available. Are those details available on the website?
So those trainings aren't available on the website, but we run trainings from time to time during the year, and there's going to be some training in September that Nara and I are going to be leading. So if you're interested, then please get in contact with us and we'll see if we can include your team in that training.
Thanks.
And questions now from Braz. Thank you for your question. How is Smart different from mStripe or Agouti? Okay, so I'm not familiar with Agouti, but I know a little bit about mStripe. So mStripe is like the government, standard government monitoring tool in India that's used in most protected areas. And it's really a tool for monitoring tigers, and it's focused on tigers, as I understand. It's also it's used for monitoring environmental features. So it's a little bit different from Smart, which is really a tool that can be used for any particular field purpose that involves monitoring wildlife or monitoring threats. So you can use Smart, you can take the Smart software and you can adapt it for your particular needs. And there is nothing that's fixed within the database that you are required to do. So I think with mStripe, it's pretty much fixed what you're able to do and what you're not able to do. But with Smart, you can actually adapt it for any purpose. So it could be monitoring wildlife or threats, or it could be doing surveys. It could be set up for use by communities. So it's a very adaptable tool, and it's quite different from MStripes. And Agouti, I'm not familiar with at all, I'm afraid. Sorry. So Sam, you showed that SMART is being used in the Congo for monitoring in tropical forests, and you showed some images of the different devices that are being used. Maybe you could tell us a little bit more about the types of devices that can be used with SMART.
I mean, I think in that case, that was one of the older devices. It was just a rugged phone that they basically decided was going to withstand the severity of the field conditions, because there, of course, it's very, very wet. And yes, so you need a device that can stand high temperature and a lot of precipitation. I don't actually know which version they're using, which mobile device they're using for the current survey, but I assume it's again a rugged device. I know we have another site in Papua New Guinea where the devices need to withstand, interesting enough, even though it's tropical forest, they need to withstand cold pretty well. So they have a sort of different climatic concerns there. But yeah, I'm afraid I don't know all the details about which devices are best. Nara, do you have any thoughts on what devices are used by the law enforcement teams in Mongolia, for example?
For now, in Mongolia, we're just using the also rocket phones and also the system monitoring and the traffic controls. For this, all three devices are using the law enforcement.
Yeah, smart users around the world are using different devices, and there are a range of rugged phones that are available on the market right now that range between $150 and $300, and these devices are, almost waterproof, and they're shockproof, and they're easy to configure with SMART. So there's many different types of devices that are available. And you can also use them on a regular smartphone. If you're doing monitoring in urban environments and you don't need the rugged aspects, you can also just use any Android device. So pretty much any device can be used, any mobile device can be used with SMART. Riaz, a question: what factors do you consider when using camera traps for point transects? Sam, would you like to offer an answer to that one?
Do you mean sort of the devices themselves? And do you
I think the question is what factors would you be measuring when using camera traps for point transects?
Yeah,
what would be the sampling attributes?
I mean, from the snow leopard, I guess, perspective, it would be pretty good for prey species. So I guess there are two ways to use camera traps in this context. One is for the snow leopards themselves, where you sort of place the cameras to really, in a way that increases your capture probabilities for the snow leopard. So it's not necessarily a random placement, although you sort of cover your whole area of interest and you take account the snow leopard's home range size. Whereas if you do it for the prey species, it actually, using distance sampling, for example, it would need to be a random design. So it's a very different way to place your cameras. And there you can, I mean, it's quite amazing to get estimates for species that you may not have density and abundance estimates for previously. And you can get estimates for rare species, but often the variance is quite high because of how the camera trapping works. And the thing you have to deal with the distance sampling element here is getting all the measurements between your animals and the camera, all those distance measurements. And so that's a huge amount of work, but there's AI options in development, AI both for sort of filtering out the blanks from your images or videos, doing species identification, and then also eventually those distance measurements. So I'm not sure if I've answered your question, but in a nutshell, that's some of the stuff that's happening with camera traps and point transects. So
Thanks, Sam.
There's a question on whether the data can be managed, the pictures. And I guess the short answer is no, it's not usually, the data are not usually managed within SMART. There we've been using other systems, something called Wildlife Insights, for example, which manages images. We've been using something called Zamba Cloud for helping us with videos and blank elimination and species ID there. So there's different tools that you would use for data management of camera trap videos or images.
Is the ultimate aim of SMART to compile collective data on species surveys, or is it just a convenient app to use across devices to collect and compile information? It's all of the above. So it's adaptable to any particular field mandate that you might have. So collecting endangered species information, collecting information on carcasses, and monitoring across a landscape, monitoring law enforcement, or monitoring the occurrence of prey species, for example. It's also possible to use it for monitoring threats. So, for example, if you've got threats to your snow leopards from snaring or from intrusions of people into an area, a conservation area, you can use it for monitoring those threats. Communities can use it for collecting incident data where people are outside and they make observations of things that may be unusual. They can be recording what we call independent incidents. And so they can be using a smartphone to just record waypoints of objects or incidences of things that are of interest. And then patrol teams can be using it, and survey teams can be using it to collect track logs so that they can measure their effort. So SMART can be used in a range of different situations for different mandates. Well, if there's no other questions, perhaps we can wrap things up here. And just wanted to thank you for coming today and for being with us for the last 2 hours. And I just wanted to leave you with some links that you might be interested in following up. So if you're interested in contacting us about SMART and its use for ecological surveys, for monitoring, please don't hesitate to contact us. Here is our email addresses. And you can also get more information by going to our website, Conservation Tools, smartconservationtools.org, and our global conservation technology team. And what we do is there too. And if you're interested in following up with us about training, please do write to us, and we'd be happy to invite you to any trainings that might be happening. We have trainings throughout the year. There are trainings that are done in person, and there are also virtual trainings. And we also have a an online resource, a basic training a course that you can do through teachable.com, which is a learning platform. If you're interested in accessing the materials on that platform, please do write to us and we'll send you the link, and that's completely free of charge. So Sam, Nara, anything else that you'd like to add before we close the session?
Just that it was a pleasure to be here.
So thank you so much, Tony, Sam, and Nara, for giving us your time. And a small request from SLN to, if you have any of these virtual trainings going on, maybe you could share the link with us so we could share with our members. I think a lot of them would be interested in any of the virtual trainings that you have for SMART. And yeah, we'll definitely keep in touch with you and bring you back again when anything new comes up. But thank you ever so much. It was so informative. We really enjoyed the session.